All right, we're gonna restart in 3, 2, 1. So we have a white card, or white paper anyway, and we're also going to have a test tube holder. We're going to have a water bath, which is a hot plate, not the Bunsen burner setup that Cambridge requests, because I don't like fire bad. And the water bath was supposed to start between 40 and 50, but it's cooled down between takes. And I have here also a stopwatch. I'm going to set the mode to the stopwatch timer mode. And also I have a glass stir rod. And I have, where's my glass marker pen? My dry erase marker, which also functions as a glass marker pen, as well as goggles. Now, here's the deal. I also have here Benedict solution. I have starch solution, reducing sugar solution labeled G. I have an amylase solution labeled E1, an amylase solution labeled E2, a distilled water solution labeled W, and that is going to be my test. So reading the paper is the first step anytime I have a lab. Forgive the mess. So the first thing I do is I'm going to read the paper. Now, considering this is the internet and you could just pause the screen, I know my desk is messier than it is in the other videos. Deal with it. All right. So I'm going to read super fast. And so you're not going to be able to understand what I have to say, so just go with it. Remember, you only have 1 hour for each question in the practical examination. You should read carefully the whole question 1 and question 2. Plan to use time to make sure that you finish all the work you would like to do. You'll get marks for recording your results according to the instructions. The enzyme amylase catalyzes the hydrolysis, breaking down the starch and producing sugars. To identify which solution E1 or E2 contains the highest enzyme concentration. By estimating the concentration reducing sugar is the reaction of E1 and E2 by breakdown of starch. Compare the non-concentration reducing sugar and compare the E1 and E2. Okay, so for each of your tests, you need to standardize the volume of Benedict solution, the volume of the samplers, and the temperature of the water bath. A1 is state the volume of the Benedict solution and the volume of each of the samples to be tested and the temperature of the water bath. That's worth 1 point. So they told me that I needed to standardize this, which means that by asking me this and then giving me a blank to fill in, what they're really asking me to do is decide what I'm going to use here. Now, my decision-making process is going to determine what I put into these answers, but there is a right general answer. The general right answer here is that the volume of each sample to be tested and the volume of the Benedict solution is based on how the Benedict's test for reducing sugars is done. And the temperature of the water bath is based on how the test is done. So there is a right general answer here, but there is no specific right number. Now, I know what I would choose. Pause the video, decide for yourself, and then I will say what I would choose. Okay, so because I know I'm going to screw up a couple of times when I do this, and I'm going to make some mistakes, I am going to choose to use 1 cubic centimeter of my sample to be tested so that I have a bunch of leftover. Whenever I make these mistakes, I can just do it again with 1 more cubic centimeter. I can just make that decision. I can do 1 more. And the Benedict solution that I need to use is the same volume or greater as this volume I'm testing. So I need to use 1. And the temperature of the volume of the water bath, I am going to test 1 whenever I'm going to test 1 cubic centimeter and 1 cubic centimeter of Benedict solution, I'm going to put those 2 cubic centimeters of total solution into boiling water. Benedict's and boil is what you do for a Benedict's reagent test. So I'm going to put it into boiling water, and the temperature of boiling water is 100 degrees Celsius. So I'm going to make it 100. Now because they gave me the units here, I only need to put numbers, 1, 1, and 100. Now, it's really easy to maintain the temperature of 100 degrees Celsius because I just turn up the dial on my water bath and let it go. I don't have to do any finicky nonsense of keeping it directly at 70 and maintaining my temperature figure and going like this with the dial every once in a while. I can just turn it up to 7 or 9 or 10 or whatever, and my water will just boil, and that's it. It will stay at 100. So it's really easy to maintain a water bath at 100. Just get it to boiling and leave it there. Now, I am given E1, E2, S, G, and W. I have B, which is Benedict's solution. I have that. I am given E1, E2, S, G, and W. I have all of those there. Now, the quantity I am given doesn't really matter because I'm going to use a lot less. I don't really care about how much I am given. I care about how much I'm going to use. So this number doesn't matter. The hazards matter whenever I'm asked what the level of risk is. Harmful irritants are high risk. None is none. Stains are low risk. All right? So read step 1 to step 6 before proceeding. Proceed as follows. Put 1 cubic centimeter of E1 and E2 into separate beakers. Notice how I'm standing over here, and my reagents are standing over here, over there. On the test day itself, I'm going to be standing with my reagents with a paper in front of me. But I'm still going to keep reading, even though I've read this now. It says do this, but I'm not doing it right now. So, because I'm reading this, I'm going to continue reading until I am done, and I'm not going to do anything until I finish reading. That is important. That is key. Put 10 cubic centimeters of S into each beaker with E1 and E2 and mix well. Leave the beakers for 15 minutes. Okay? Am I going to actually leave the beakers and walk away? Absolutely not. I am going to leave those beakers alone and continue on while during that 15 minutes I am required to set up the water bath and ready for step 6. Prepare the known concentrations of reducing sugar solution. So it tells me that for 15 minutes I'm not going to just walk away and have a nice break. I'm going to be doing stuff. Set up the water bath to heat the temperature as decided in A1. A1 was over here. I'm going to do these things. So decide which concentrations of reducing sugars to make using serial dilution. Using 20 cubic centimeters of the 0.4% reducing sugar solution, G, which was listed here, I'm going to start a serial dilution, reducing the concentration by half between each concentration. And then I'm going to use this diagram here to show how I'm going to reduce the 3 further concentrations. I'm going to make this 3 more times. I'm going to take 20, 20, 20, and 20 cubic centimeters of half each time. Half of 0.4 is 0.2. Half of 0.2 is 0.1. Half of 0.1 is 0.05. Percent, percent, percent. I must use units. I must use units. I must use units. I must use unit. That was weak. All right. Now, using this diagram, I have these arrows here. This arrow is devoted to water. Because I am diluting by half each time, I need to add distilled water W. I am taking out 10 cubic centimeters. I'm taking out half and putting in the same half of water. So I'm taking out 10 cubic centimeters of this value, and I'm copy, paste, and changing 20 to 10. And then I'm putting 10 cubic centimeters of W up here. And I'm adding those two together to 20 cubic centimeters of that 0.2%. And then I take these arrows and I just shift them down here. And I replace that 0.4 that was here with a 0.2 over here. And then I shift down here. And I replace that 0.2 with 0.1. And that's all I have to do. And that is worth 3 points to me. That's all I have to do in a serial dilution question. That is it. That's how it is done. Now I can draw that on a figure at a later time. Right now I feel like I'm on a roll. So number 5, prepare all the concentrations of a reducing sugar solution, as in figure 1.1 in the containers provided. So I'm going to do that later. You are now required to test for the concentrations of reducing sugar by the Benedict's test. Test each sample separately using the volumes decided in A1. Record the time taken for the appearance of any color change. If there is no color change after 120 seconds, record more than 120. This tells me 2 things about what I'm going to be doing. It tells me that I'm going to be recording time taken for the appearance of any color change. That is my dependent variable. I'm also going to be testing each sample using the volumes decided. And I'm going to prepare the space below, which means I'm going to make a table, a boxed-in table. And I'm going to record only my results for the known concentrations of reducing sugars. That sounds to me like an independent variable. So I'm only going to record the known concentrations that I prepared here. So I'm only going to have 4 independent variables in my table. And I'm going to have seconds, time taken in seconds. And I'm not going to have any units in my table. I'm going to have time for appearance of color change in seconds. And I'm going to have whole seconds only. And if it goes more than 2 minutes, which is 120 seconds, I'm going to write more than 120. Now, in part 4, using my results for E1 and E2, which means I'm going to be testing E1 and E2 plus S, plus that starch, which it told me to do in part 1 and 2. Let's scroll this down. I'm going to record the time taken for the first color change in E1 and E2. And then using these 2 times, I'm going to state which of these 2 solutions has the higher concentration of reducing sugars. Remembering that a higher concentration of reducing sugars will react faster in the Benedict solution test. Faster reaction means lower time. And then using the results from A3, which was the table of my known concentrations, I'm going to use that to estimate the concentration of reducing sugars in the solution. Remembering, of course, from way back in the beginning, that the enzyme amylase, which is what is found in E1 and 2, which is an amylase solution, is responsible for hydrolyzing starch into reducing sugars. Now, going back down here, I can then estimate the concentration of the amylase now found in the in these solutions. Now in part 5, describe how I can modify this investigation to follow the time course of hydrolysis of starch by an enzyme E without the use of Benedict's solution. Remembering that enzyme E is amylase, that amylase breaks down or hydrolyzes starch. What other test for macromolecules do I know of? Tests for starch. And that's not a question for the peanut gallery to answer. That's a question for the watcher of this video to answer. And if you haven't answered by now, perhaps editing in post will just flash it right here on the screen. All right. So that's worth 3 points to you, describing how you would test for starch. without Benedict's solution. Remembering, of course, that testing for Benedict's solution, you are testing for the appearance of reducing sugar by breaking down starch. The other way, you would be testing for something else. You would do it some other way. Now, part B we can discuss in another video. Right now, I'm going to take some time to do this reaction. All right? I'm going to come over here and we're going to have this time. Now, I'm going to scroll back and walk through my steps. Going back to step 1.
Stanley, we're going to hit the camera for a second.
Okay.